In today's lesson, we are going to learn why slope-intercept form of a line, which we began talking about in our work yesterday, is so helpful for graphing a line. So as a reminder, y equals mx plus b here. This is what we call the slope-intercept form of a line. It gets its name because we learned last time that this number m in front of the x indicates the slope of the line. And we did that by finding the change in y divided by change in x in various examples. So that's the first thing to keep in mind here. The second is that we're going to have a name for the point 0, b. If we substitute 0 for x in the equation y equals mx plus b, so say I'm building points on my line and I decide to find what is the y coordinate of the point that is a solution to the linear equation y equals mx plus b. So in that substitution, I would take y equals m times 0 plus b. No matter what number m is, m times 0 will be 0. So I get 0 plus b, which is just the number b. And that tells me that the point 0, b will in fact be a point on my line because it'll be a solution. It'll be part of the graph of the equation y equals mx plus b. Now, if the x coordinate of that point is 0, and I were to see where it was located, it would have to live on the y-axis. And because it lives on the y-axis, its x coordinate being 0, the only thing I need to do to find it is wherever b is. So if b were a positive number, then we're looking at a solution point up here. Or if b were a negative number, then that point b would be down here on the y-axis. Wherever it would be located, my line would have to pass through that point. Because that would be the only point where the x is 0, that would be part of the graph of this equation. It is the point where my line will intersect that axis. For that reason, we call it the y-intercept. So there'll be this point, y-intercept. We are going to graph two examples of lines in y equals mx plus b, our slope-intercept form, by identifying the slope, identifying the intercept, and using that information to graph the lines. Let's look at our first example. Example 1, graph the equation y equals 2/3 x plus 1. Name the slope and y-intercept point. Let's go ahead and do the second part first because it will help us in solving this problem. So we will make our first step to find the slope and y-intercept. To identify the slope, I'm looking for that number m, the number that is the coefficient on x in my linear equation when it is of the form y equals mx plus b. So in this example, I look at the line and I see that the coefficient in the mx plus b form that we're in is 2/3 on x. So I'm going to declare that the slope of this particular line should be m equals 2/3. Next, I need the y-intercept point. Remember, that is the point where the x coordinate is 0. So I can evaluate the equation of this line when I substitute 0 for x to remind myself of what that b is. So the y-intercept point, I'm going to take y equals 2/3 times 0 plus 1. So I'm using the 2/3 from the slope, and then the 1 was the remaining part of my equation. What do I get as my value? You can type this in the chat, you know this. Great, 2/3 times 0 is 0. This is y equals just 1. So we get y equals 1. Therefore, the y-intercept point is 0, comma 1. And after we've gotten some practice with this, as I mentioned before, the number that is added on here, the number playing the role of b, I'm circling it real big, that number there always happens to be the y coordinate of this y-intercept point. So as you build skill in this, you are fine to just write that point as 0, comma, whatever the b is. You do not have to do the evaluation to check it, but I want you to practice it a couple times to see that it works. Because we're going to graph this line, let's go ahead and graph this point 0, 1 that we know is part of our line. We're going to plot that as part of our line. So we're going to make our first step, plot the y-intercept to do my graphing. So I said that point was 0, comma 1, so I find the y-axis and I plot the point 0, comma 1, which is going to land right there at the y equals 1 point on my vertical number line on the axis. That is my y-intercept. Next, I need to find the slope, or I need to use the slope to find additional points. Because I know that the slope in this example is 2/3, so my slope is 2/3, that tells me that the ratio I should find in any slope triangle I draw is 2 units up per 3 units right. This is because we know that the ratio of movement in the vertical direction, where positive means up, to movement towards the right should be the value of the slope. So here I'm not using the slope in its unit rate form, but as a ratio. Therefore, the easiest way to find another point that follows that would be to draw a slope triangle that moves 3 units right and 2 units up. That's what I'm going to do. So I'm going to move 3 units right. Watch my green line there. So I moved 3 units right and 2 units up. This next point that I identified when I've done that movement must also be a point on my line. Let's check that the point 3, comma 3 is on our line. Is 3, 3, this point I found doing this math on the line? Well, remember to check if a point is on the line or that I'm checking to see if it's a solution to the linear equation. So I'm going to replace y with 3 because that is the y coordinate of the point. And then I'm going to put, is this equal to 2/3 times the x coordinate, which was 3 in this example, plus 1. So there's the x coordinate showing up. Well, 2/3 times 3, that's 2/3 times 3 over 1. So that's 6/3, or the number 2. And so I get that this is 2 plus 1, which is in fact 3. Yes. Therefore, I have found a second point on my line. Because I have 2 points that are both solutions to the equation, and we know slope should stay consistent, once I have 2 points, I can draw the line through that, and I found my line. So let's take a straight edge out and do that. There's my straight edge. There's my line. So my second step, as we saw it here, after plotting the y-intercept, was to use the slope to determine a new point on the line using the ratio, by using m to make a slope triangle. And then step 3 is to draw a line between my 2 points.